Jessica Johnson. I am part of Team 16. We are doing forest fire robots. These forest fire robots are part of a larger team, all meant to survey. The problem that we're trying to address is that of information. The forest fires and the city needs to know how big the fire is, what the air quality is. So we have 4 robots to address this. Air quality, one to measure the temperature to see the extent of the fire, another one to measure if there's possible large animal or human life, and then my robot is one to identify a water source within a 10-mile radius of the fire to aid in putting it out. The mechanical design is shown here, a top view of the hovercraft, and then the bottom is a video showing various angles. Some key features of this is that because the FAA does not allow helicopters and drones to run at the same time, this has to be on the ground. Essentially, it's a drone that can't go more than a foot off the ground because it's a hovercraft. It's going to have a hefty fan to cause that lift, a cone to keep the air in, fans on the back to direct, and then you see sensors, 1 on the front, 2 on the back. These are going to be to measure temperature and ultrasonic sensor to measure an object in the front. This is stayed basically the same, except for the model is more aerodynamic rather than a circle. The circuit has also remained largely the same. You're going to see the 2 sensors, the temperature and ultrasonic. The difference mainly is in the lights to indicate what the temperature is at. The actuators are going to send information back saying if a possible water source is found or if no water is found or if an object is there and the bot needs to be redirected. The flow chart is at the top and there's snippets of code on the bottom. The snippets of code are going to show the forward movement when the air temperature is either hot or air temperature, and the other one is if a possible body of water has been found because it's cool in a large area. The flow chart shows that first air temperature is measured, and then the temperature sensors are going to measure against this. If it's warm or air temperature and there's no object in front, the robot's going to move forward. If any of those things happen, however, the robot is either going to reverse its motor and turn around or ask for directions from the central hub. With this information, it will communicate possible locations of the water source and its distance from that central hub, the fire, where it started. The budget is going to be about $280 for this prototype. This is optimal because all of these components shown here are essential to the function of this robot. There's nothing extraneous. Also, when you compare the cost of this robot to the damage that fires can cause, even human life, this really is a balance and appropriate for what is needed. The demonstration here at the top is of the circuit running. A light will first showing that the air temperature is hot. The motor will then run forward. This is the beginning part where the robot is moving away from the fire, so it will be hot. The next on the bottom is going to be how our robot interacts with the environment. It will have a target or 2 in which represents a body of water. It will just mark that spot. And then the other one represents, that's moving now in black, represents another personnel coming to collect the water to bring to the fire. In summary, the object that we are trying to do as a team is to get information about the forest fire to aid in its containment and in subduing the fire. My robot will identify water sources that later can be used in subduing this fire. The robot design is going to be a hovercraft to not interfere with the FAA regulations concerning a helicopter and a drone flying at the same time. Hovercraft was chosen to glide over possible obstacles and will be hefty enough in design to lift up on the forest floor. Thank you. And then following slide is going to be my references. These references mostly were component parts, also articles talking about the water temperatures and fire temperatures and the dangers of fires and what's needed to solve and contain them. Thank you.